Okay, hello, Math 7 students. This is Open Up Resources, Unit 3, Lesson 10, Distinguishing Circumference and Area. We've had a lot of practice with circumference, a lot of practice with area. We've even done stories for each. But now, this is kind of a mixed lesson, where, based on the situation, based on what it's asking us to do, you need to figure out if circumference or area is more appropriate. To get started, we do have this warm-up, filling the plate. So, how many cheese puffs can fit on the plate in a single layer? You need to be prepared to explain your reasoning. Pause the recording so that you have a chance to work through this on your own, and only continue when you're ready to check your answer. Okay, let's go over this. Who would like to share their thoughts on how they approach this problem? Okay, let's start with Joshua. Okay, so let's pause for a second first, because as far as this recording is concerned, we haven't done any of that. Let me give some background information. On a previous lesson, we did another estimation 180 exercise where we estimated and then discovered how many cheese balls fit on this tray. And what was that number, Joshua? 286 on the tray. Okay, continue with that. Okay, so that sounds quite tedious, counting every single cheese ball that is visible so that you know how many are not visible, therefore fitting on the tray. Okay, tedious, that would probably work. Tell me what you ended up with. Oh, sorry, so 156 are visible? And that gives you a total of 153? 153, okay. 156, thank you. Okay, that would work. What if we didn't do this prior? Is that strategy going to work if we didn't previously do our estimation 180 to know how many are on the tray? No. So that's a strategy. Okay, tell me another strategy that was used. Sophie. Okay. Okay. Okay, pause for 1 second. Let me demonstrate that because I like this thought process. You decided to find the diameter of the plate in cheese ball units, right? Okay. Now I have the advantage of I can trace it and then literally just copy and paste, right? You didn't have quite that same ability. So when I'm doing this, let's see, I'm almost done. What's the diameter according to this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And that you said you got 11, right? Okay. Now with a diameter of 11, and yes, using technology, I can see I've got like half of a cheese ball here and half of a cheese ball here, but Sophie said a diameter of 11 with her drawn cheese balls. What would I do with that diameter to continue this problem? Okay, Davin, what would you do now that we know that the diameter is 11? Okay, the diameter divided by 2 is equal to the radius. And so that would give us a radius of 5.5. Okay, and now what? Square the radius. 5.5 squared. I got 30.25. So there's 30.25 cheese balls on here? Oh, then multiply it by pi. Why are we squaring the radius and multiplying it by pi? What does that really mean? What are we doing, Luke? Yeah, we really need the area of the plate. So that's why we're squaring the radius and multiplying it by pi, because it's going to give us the area, which really truly is all of the cheese balls that would fit on the plate, right? That's what that area is filling this entire surface. So r squared times pi, I end up with 95.03. So we're going to just round that because we're going to go with whole uncrushed cheese balls. So about 95 cheese balls. Does that sound good to you guys? Is that a calculation that makes sense? Cheese balls. All right, that was using a a diameter of 11. What if we, instead of looking for the entire diameter, what if we just looked at the radius? What would that be? How many cheese balls to go from here to here? And again, I've used technology to trace. So 1, 2, 3, 4, 5, 6, 7, or do you want to say 6.5, 5? What do you guys want to say here? Because I can maybe squish them a little bit more. Can I get that 7th one all the way on? I mean, it's hanging off the edge a little bit, but is it still going to stay on the plate? Yeah. So we can maybe change that radius from a 5.5 to 7. Let's try that then. What is a radius of 7 squared multiplied by pi? You have calculators. If you haven't done it already, help me out. Liv. About 154? And you guys get the same thing? Fantastic. Okay. Who is closest? I have to pause the recording because I'm going to go and play a video from another site that I don't own the rights to. So I'm going to pause this recording, but I'll freeze frame it on the answer. All right, and there is that big reveal. 156 cheese balls fit on the plate. So let's talk about strategy here. Did Joshua's method work? Yes, but it only worked because he knew how many were on the tray. If we didn't have that prior knowledge, then what strategy is one of the best ones to use? Counting the radius and finding the area. That's literally what we are asking for. If it's going to fill the entire plate, then that would be the area. That means we need to find the radius. We can be precise with that radius, maybe squishing them together. You saw how those were kind of squished on that plate as much as possible. And we get a little bit more precise estimate of 154 cheese balls when we squish them together for a radius of 7 cheese balls. 5.5 cheese balls was a little bit too small, but 7 cheese ball radius was perfect. Let's move on to the next problem. You are actually going to do a card sort. So at your tables, you have been given a set of 8, I believe, 8 cards. You need to sort the cards into 2 groups based on whether it's circumference or area that it's asking for. Okay, so that's all we're going to do right now. Here are those same cards. Let's see, I'm going to have to go this way. There's those same 8 cards so that students can, watching the video, can pause the video. You won't be able to move them around and sort them, but you can go through them and say, oh, I believe this one is area, or I believe this one is circumference, and kind of give them those labels. So pause the recording on this screen so that you can go through that exercise as well. Okay, only continue on if you've already sorted these and you're ready with the answers, because we're going to check them right now. Question number 1. How much fabric is needed for a round tablecloth? Is that going to be circumference or diameter? Just kidding. Circumference or area? Which one is that going to be, Grant? That's going to be area, yes. Question number 2, which category did you put it in? How fast do you go when riding on a Ferris wheel? How fast do you go when riding on a Ferris wheel, Dylan? This one is circumference. Question 3, where did you put it? How much green space there is inside a traffic roundabout. There's a key word there, Cambria. Area. And the key word is what? What was the clue? Inside. It's inside of that traffic roundabout. Question 4, how many square inches of cheese fit on a slice of pizza? Davin. Area. Yep. Notice that it's not on the whole entire pizza, right? It's a slice of pizza. That's going to come up later. Question 5, how many times must a horse go around a horse walker to walk 1 mile? Part of the reason why students in the past have struggled is because they don't know what a horse walker is. So here's some examples. You guys see this? A horse walker is literally a round thing. They've got these little like pull leash things that kind of take them around. Excuse me. Zuri. It is the circumference. And I just realized that that cut off because I wasn't actually writing on the screen part, so circumference is finished there. Circumference, and what is the key word that reminds us that it would be circumference? Do you know what that key word that you see in there is? Circumference. Luke, what's that key word? Around. Yep, we're going around the outside. Okay, question 6. How many feet are traveled by a person riding once around a merry-go-round? Trace. That would be circumference. Again, key word is around. Okay, Question 7, how much room is there to spread frosting on a cookie? How much room to spread frosting on a cookie, Bella? That's the area. Where does the frosting on the cookie go? I'm going to go back to the picture again. Are we putting frosting just on this outside edge? That would be weird. I would not want to eat a cookie that way, right? The icing has to cover the entire surface of that cookie. That would be area. Question 8, how far does a unicycle move when the wheel makes 5 full rotations? Let's go Oren. This is circumference. These images can help us understand different parts of what we're going to be doing next, okay? So the first thing we need to do is I'm going to pick one situation, only one, just for, let me look at the time. We might choose 2 situations that I want everyone to work on. And what I want you to do is first, we're going to make an estimate on the measurements. That's the first thing we're going to do. For example, let's do one of them together. This is a traffic roundabout, right? And you see how the traffic roundabout has been covered with green stuff, grass and shrubbery and all of that other stuff, right? So we need to estimate some measurements of this roundabout. Now imagine cars have to drive around it, right? How big is a car? Is it bigger than you? All right. So would it be safe to estimate that the radius of this roundabout is 5 inches? Would even 5 feet make sense? No, because if it were only 5 feet, think about, oh, that's not what I want. I want this. There we go. Think of that in relation to a car driving around it. Is 5 feet going to be an appropriate radius? So quickly talk with your groups. Let's come up with an estimate. What is an appropriate estimate of the radius of a traffic roundabout? Quick discussion at your tables. Okay, now come back to me. What do you think is an appropriate measurement for the radius of a traffic roundabout? Carter. 20-ish feet. Yeah, I think 20-ish feet is probably appropriate. This is a really massive roundabout, so this one probably wouldn't be 20 feet. It would probably be a bit larger, but yeah, I think that 20 is at least a decent starting point, a 20-foot radius. Now, once I know the radius, what would I do to answer that question? Remember, that one is asking how much green space is there inside a traffic roundabout. We need to find the area. So what would my next step be? How do I answer this question about how much green space there is inside a traffic roundabout? We're really asking the area and we're estimating that the radius is 20 feet. What would my next step need to be, Luke? Yes, we need to square 20 feet. After I square 20 feet, is that all? What else? Yes, we need to multiply it by pi because that is what we're finding. Area is the radius squared times pi. So I'm squaring our estimated radius, multiplying it by pi. Let's do that together. 20 squared times pi. Quite a large number. 1,256. What's the units of measure here? Try again. Is it feet? Luke, what is the units of measure here? Feet squared or square feet, exactly. I included the decimal when I looked at my calculation. That decimal of 0.6 is probably going to make a difference. So feet squared or square feet. That's what you're going to do for the 2 problems that I choose for you. If you have time, I encourage you to do it with as many as possible. But here's what I want you to focus on. These are the problems. Let's choose question 6. And let's choose question 7. If you have time, because many students in class will finish a little bit quicker, I also want you to do question 8 and question 4. But 8 and 4 are secondary. Don't do 8 and 4 until you have done questions 6 and 7. Go through that process. Begin by making whatever estimating whatever measurements you need to estimate. You can use these pictures up above as reference if that helps. We're going to pause recording as students work on this. Okay, let's go over these. Question 6. Circumference. In order to calculate circumference, what would I need? What is the measurement that I would need? Davin. Diameter, because circumference is pi times the diameter. So again, we can go back here. If I need this diameter, let's estimate what that diameter is going to be. What estimate did you come up with for the diameter? Luke. Great. I love it. We don't actually have one at our own school to really make a precise estimate, so just going off of what I've seen in the past, I think that's going to be great. So a 16-foot diameter, we're going to multiply that estimated 16 feet by pi in order to find our circumference in 16 times pi. Since Luke came up with that estimate, Luke has that calculation ready to go. What did you get? 50.26. And what is the unit of measure here? Feet, yes, because we're traveling 50.26 feet as we go around. They are not feet squared that we're traveling, they're just feet. Let's move on to number 7 then, area. How much room is there to spread frosting on a cookie? If I'm spreading frosting on a cookie, that's area, which means the measurement that I need to estimate is the radius, right? So what radius do you estimate for a cookie? What would you say, Zuri? Okay. Okay. A 2-foot cookie, I'd like to see that. But yeah, I think a 2-inch cookie, it's a small cookie, but yeah, a 2-inch cookie for for a radius? No, that's a pretty good sized cookie. You're right. So the radius would be 2 inches. Let's calculate that area then. R squared. So 2 squared multiplied by pi. And Zuri, do you have that calculation for us as well? Oh, okay. So when you estimated 2 inches, you said that would be the diameter. That's a very small cookie then. I'd rather a radius of 2-inch cookie, but that's okay. We'll go with what you said. A diameter of 2 would make... Just waiting for my class to get back under control again. A diameter of 2 would change that, so the radius is 1. And so the radius of 1 squared then multiplied by pi is going to be, I know this one, 3.14. And what would our units of measure be for this, Zuri? 3.14 what? No. What would the units be? If the diameter was 2 inches and the radius was 1 inch, what is this measurement here? This 3.14 what's? Anyone want to help her out? Yeah, you got it. You got it. Inches squared or square inches. Fantastic. If you also finished up 4 and 8, that's great. Here's the only things that I'm going to say. Since I'm asking how many square inches on a cheese fit on a slice of pizza, we would have our area, but then what would I need to do with that area? Luke. Yep. Mm-hmm. Exactly. Yeah, we'd have to divide it by 8 to find out how much is on one slice. Exactly right. Question 8, how far does a unicycle move when the wheels make 5 full rotations? You would find the circumference, and then what would you need to do? 5 full rotations. What does that really truly mean? Someone besides Luke who's answered all of the last 12 questions. Dylan. Yeah, going around it 5 times. So we'd have to take that circumference, whatever we ended up measuring, and multiplying it by 5. Exactly right. Up here, it would have been the area divided by 8, since there's probably 8 slices of pizza, and here it's a circumference multiplied by 5. So with that in mind, let's solve some more problems. Here are 2 students' answers for each question. Do you agree with either of them? Explain or show your reasoning. So here's a picture of a merry-go-round. How many feet are traveled by a person riding once around the merry-go-round? We already did a problem kind of like that, right? We had our own merry-go-round issue. Claire says the radius of the merry-go-round is about 4 feet, so the distance around the edge is 8 pi feet. Andre says the diameter of the merry-go-round is about 4 feet, so the distance around the edge is 4 pi feet. So, who do you agree with? We're going to pause recording as students debate and discuss. All right, Grant, what do you think? Yeah, they're both doing correct things, aren't they? If the diameter is 4 feet, the diameter multiplied by pi is how we find the circumference, so that's correct. And if it is a radius of 4 feet, 4 multiplied by 2 will give us the diameter, and then that multiplied by pi is going to give me the circumference. But the question is, which one has the more reasonable answer? They're both correct in their calculations. Which one makes more sense? A diameter being only 4 feet, or a radius being 4 feet on a merry-go-round? Which makes more sense? Dylan? Yeah, I would agree. So mathematically speaking, they are both correct. But when we're trying to make some estimates, some perspective, and maybe seeing a merry-go-round to see that a diameter of only 4 feet, like we have students in the class, all of you are taller than 4 feet, right? So a 4-foot diameter for a merry-go-round is not really reasonable, but a radius is. So I would agree with Claire. I'm still waiting for students to stop calling out. Claire's is more reasonable only because she estimated the radius at 4 feet. I'm going to put that down here. Claire's estimate is more reasonable. Although both calculations are correct. Let's take a look at the next one. How much room is there to spread frosting on the cookie? Again, we've already answered a question similar to that, so let's read through these statements and see which one we agree with. Claire says the radius of a cookie is about 3 centimeters, so the space for frosting is about 6 pi centimeters squared. Andre says the diameter of the cookie is about 3 inches, so the space for frosting is about 2.25 pi inches squared. Pause the recording as you debate and discuss. Ready, set, go. All right, Carter, what do you think? Neither of them did them correctly. What do you mean by that? Great, exactly. So what did she find? 3 times 2 times pi, what is that really? Nope, circumference, or sorry, I gave away the answer. Radius multiplied by 2, then multiplied by pi, that's circumference, right? So did she calculate the area correctly? No. No. So I agree, we can't agree with Claire because she did the radius multiplied by 2 instead of the radius squared. Carter? Yes, that is true. That is a good point. She did correctly use the units of measure. She knew I'm finding the area, so I know it's going to be centimeters squared, but she didn't correctly find the area. She did r times 2 instead of r squared times pi. So she misused her formulas. What about Andre? What don't you like about Andre's, Carter? Double check that. What would the radius divided by 2 be? Sorry, yeah, the diameter divided by 2. And what is 1.5 squared? Yep. What is 1.5 squared, Gideon? Yeah, it is 2.25. So, taking that radius squared, multiplying it by pi, would we get 2.25 pi? Yeah, we would. So, Carter, have you changed your mind? Who do you agree with? Andre. Andre did the correct formula. All right, let's move on. All right, let's go on to the are you ready for more? And only do this if you really, really, truly are ready for more, because it's an interesting problem. A goat, that's going to be point G, is tied with a 6-foot rope to the corner of a shed. And the floor of the shed is square, whose sides are each 3 feet long. So this shed is 3 feet by 3 feet by 3 feet. And the shed is closed, so the goat cannot go inside. All of the space around the shed is flat and grassy, but the goat cannot reach any other structures. So, what is the area over which the goat can roam? Now, upon first inspection, we're going to notice that what it's giving us right here is a radius, because the goat can kind of travel in this area here. Uh-oh, where'd my cursor go? The goat can just sort of travel in this area here, roaming. So we can kind of see that that would be a circle taking shape. Let me get that circle here in place. There we go. Okay, so it might appear that the goat can travel and go anywhere in that whole area covered by that circle. But we have to also take into consideration how that leash is going to impact the places that the goat can go. It doesn't just keep him like tethered into this certain area, it also is going to kind of do some interesting things with the shed. So let's imagine we're the goat and we're wandering. Oops. We're wandering. I'm going to actually lock that in place now, I think. Circle. There we go. So the goat is wandering. He can get through all of this place here, and then something interesting happens right here. Right? Because he hits the wall of the shed with that leash, and he can't go over here because look at that leash is now somehow magically going through the shed. So something happens right here. We need to stop and think about what is happening right there at that point. He's used up 6 feet of his leash, 3 feet he's used up just to go up against the side of the shed now, which means he only has 3 feet left. And this now acts as like the new pivot point. So think of it this way. Now the goat, let me get my new radius here. The goat now can only go in this vicinity with our new 3-foot radius, right? So again, what does that look like? Let me get my other circle up here. With this new sort of pivot point, that's the area that he can travel as he continues to try, oh, wrong way. As he continues to try and pivot around this way using the remainder of his leash to take him over to there. So let's think about that. How much space is he able to cover? All right here. Pause the recording and give yourself another chance to kind of reevaluate this problem, and then we'll continue to go over it. All right, let's go back. Let's get that goat reset to its original position. So there's that goat again wandering. We kind of got this figured out as he can roam and his leash is free flowing until again this direction something interesting happens and we're seeing the same thing where he's used up 3 feet of his 6-foot long leash just going there up against the shed, which means he only has 3 more feet of leash from here on out and a new pivot point to start pivoting around. So it's almost like again a radius of a new circle where we can only travel that distance there. What does that look like? I'm going to get another one of these circles. It's going to look something like that. Where again, with that new pivot point, the goat can travel here, and that's as far as he can make it. So we've got this space. That looks like it's a quarter of a circle this size. This space, which is a quarter of the circle of the same size. And don't forget all of this other space out here, right, which looks like it's about 3/4 of that large circle. Pause the recording one more time. with all of this new information and see if you can actually figure out the area that that goat can wander. So this large purple circle, we have a radius of 6. To find that area, that is going to be 6 squared times pi. But remember, he doesn't actually have that full circle. This whole quarter of the circle he's not able to get to. So that's why I'm going to multiply that by 3/4 because he only gets 3/4 of that circle. Now we also need to take into consideration these two green spots. Those green spots each have its own new radius of 3. So radius of 3 squared multiplied by pi. It is 1/4 of a circle. So just multiplied by 1/4, but we do have 2 of those. So you can multiply that by 2, or you can just say a quarter and a quarter of a circle are going to make half of a circle. So we've got to calculate those and then add them up together. Here I have 6 squared times 3/4 times pi. This is equal to 84.823 feet squared. And these two pieces here, 3 squared times 1/2, then multiplied by pi, is equal to 14.137 feet squared. Adding all of that up together, we get the total area that the goat can wander. I'm getting a grand total of 98.9601 feet squared. Or I think it's safe to say that that is about 99 square feet. All right, let's summarize. I've already highlighted the important parts. In our Lesson 10 summary, we have seen that we have practiced circumference and we have practiced area. We've seen them in stories now as well. Sometimes a story is going to ask or give a situation where we need to find the circumference of a circle, such as the length of a circular path, the distance a wheel would travel in 1 complete rotation or in 5, the length of a piece of coiled rope, etc. There's also going to be some times where we need to calculate the area of a circle. Some examples of that would be the amount of land that is cultivated on a circular field, the amount of frosting needed to cover the top of a round cake, the number of tiles that we would need to cover a round table. In both cases, the radius or the diameter is all that we need to make that calculation. If I give you the diameter, we can divide by 2 to find the radius and find the circumference. If I give you, find the area. If I give you the radius, we can multiply that by 2 and use that to find the circumference. So no matter which I give you, the radius or the diameter, we can be successful in any one of these types of problems. So here is our cool down. A circular lawn has a row of bricks around the edge, and the diameter of the lawn is about 40 feet. So what is the best estimate for the amount of grass in the lawn? The diameter is 40 feet. And so if I want to know the area of that grassy space, we need the radius. So 40 divided by 2 means that the radius is about 20 feet. So what is the best estimate for the amount of grass in the lawn? That's going to be 20 squared times pi. And 20 squared times pi is equal to 1,256.637. Which of these is the most appropriate? None of them are exact, right? And that's okay. But it looks like C and D both have 1,250. So we need to choose between these two, which is going to be the best answer. Well, which is it? It comes down to units. Is it feet? Or is it square feet? And remember, because we squared the radius, it's no longer feet, it's feet squared or square feet. So D is the most appropriate answer there. What is the best estimate for the total length of the bricks? We've got these bricks that are going around the outside. So what is that best estimate there? Again, we've got our diameter of 40. We multiply that by pi. And 40 multiplied by pi is about, that's our circumference, that's about 125.6637.
So which one of those is going to be the most appropriate? 125 square feet, 1,250 or 1,250 square feet. Obviously, it's going to be one of these 125s. Well, which one? Remember, we're just using a measuring tape to go around the outside. We're not using square units of measurement, so that is going to be A, 125 feet. Your homework is the Lesson 10 practice problems. Here is something that is worth pointing out because this has been a struggle in years past. The city of Paris, France, is completely contained within an almost circular road that goes around the edge. So here's what I would like to point out. It is an almost circular road. It is not perfectly circle by any means, but it's almost circular. And we can see the circular map. It says to estimate the circumference of Paris. And it does give us this scale. Oops. Gives us this scale here that this is about 1 mile. So we can take that, use that to kind of measure and see how many of these 1 miles we can fit. Let's lock these in place. How many of these 1 miles we can fit. Here's what I want you to be careful of. Remember, we're kind of estimating the diameter or the radius of this almost circular road, not the entire circular shape. For example, how many of these does it take to go all the way through to the other side? Notice I'm not going from edge to edge of the image, I'm going edge to edge to the road. So it looks like 1, 2, 3, 4, 5, 6. Looks like the diameter is about 6 miles. So I just want you to take that into consideration as you're working on this problem. Just be careful that you are not going all the way to the edge of the entire image. That is it for today. Thanks for watching, and we will see you next time.